So we're going to run our system and test it on this local privilege escalation vulnerability. We download this from the exploitdb database. It contains samples of verified CVEs as well as the vulnerable app that they're from. In this example, an HP application, an HP service is running, arbitrarily running any file that's named program.exe. This might be used for malicious purposes if an attacker were to rename a malicious payload into program.exe and then load it into this service. And then all of a sudden you can run any sort of file on that system. So the exploit here is with the HPM service file. We've loaded that service file into our instance of OGhidra here, and then we have here our instance of OGhidra, and then we're going to ask a very quick question. Help me identify any potential vulnerabilities within this application. Try to identify any inputs and inputs. So we're going to have a very generic prompt. Help me identify any potential vulnerabilities within this application. Try to identify any inputs and how this application interacts with the operating system it's run on. We're just going to say go. And as you can see, we're running kind of a pretty generic model. So we're running Gemini 3 Flash, and we're also running their embedding model. So we can see the AI first comes up with a quick plan. This plan is to kind of help it figure out what to analyze. So it wants to begin its initial reconnaissance by listing imports and exports. That will quickly allow the AI to identify what capabilities the binary has. So this is where it does its like metadata analysis phase. And then through that, it'll kind of iteratively go through anything that it looks interesting, find references, and start decompiling functions. We can also see that here. So this is kind of the eyes of the AI, of what the AI sees, the kind of data that we're passing into it, where we're showing first listing a bunch of imports and exports, and then it starts from that baseline. It starts to decompile some functions to try to solve our goal of identifying potential vulnerabilities. Okay, great. So it seems our system finished. It's quick. It's identified this binary as a system utility for HP environments, which is correct. It achieves this by interfacing with the Windows management in framework, monitoring specific registry keys. And some for the security assessment, we have this main assessment where there's a process execution context where the utility utilizes a process create, given that the hardware often requires elevated privileges to interact with system drivers. There's a high likelihood that this binary runs with the system authority with an administrative context. Amazing. So this is looking right on track with what we've identified as our vulnerability, where we've originally stated that because it interacts with hardware, it runs applications with a high level of privilege. This application relies on external inputs from WIM events. These registries are writable by non-privileged user. An attacker could modify them to redirect the binary's execution flow. So that's pretty much exactly what was identified in the stated vulnerability. So as you can see, this is a pretty nice way to either verify or vet binaries for vulnerabilities in kind of an automated fashion that doesn't require kind of an infinite amount of analysis time from a reverse engineer, as we have a large quantity of these binaries, and understanding how each function interacts with each other is much more easily done with AI.